Good morning.
Good morning, sir.
Yeah, good
Good
morning.
morning, sir.
Sir, can you hear us?
Yes, yes. Good morning. Okay. So yesterday we understood a few more programs. Okay. One last program which I was showing, that inserting an element into the array at the given position. Okay. So that example we will discuss now, and then we'll go to the next topic, structures. Okay. And we will be again discussing the structures in detail. I'll share my screen. Okay. Yeah, 1 second. Okay. So this one program inserting into the array at the specified position. Okay, we'll discuss this, and then we'll go to the structures. Okay. Now, as I was explaining yesterday, if you want to insert it to the shorted array, you don't require the position. Now, in case if you want to insert it into the unsorted array at the desired position, so then you got to read your own position. Now, what we are doing, along with this element which I want to insert, I'll also be reading the position, the desired position where I need to insert my new value. So, and then the prompting message were not there, otherwise it will confuse us. Enter the elements of the enter the number of elements, number of array elements, and then we are reading here, and after that let me say printf enter array elements, enter array elements. Now, so you're reading array elements here, and then this is what one more confusing, printf enter the position to insert new value, and then I'm reading the position here to POS variable, and next one more printf, enter the new element to insert. So reading the element here to ELE, and then I check if position is greater than n. So n is my total number of array elements. So if the position what I am giving, if that itself is greater than n, then I say invalid input. Okay. And in the else part, if this condition is not true, I come here. Now same thing as we did for inserting it into the shorted array. Similarly, what I do, I initialize it to n minus 1. Okay, because we are starting the array index while reading. So we are starting from 0 here. Correct, no? The first element of the array will be stored at the 0th index, and you have the last element stored at n minus 1. Correct, no? That is what I am assigning to I, and then I check I greater than or equal to position minus 1. So the position what you are reading here. So as long as this condition is true, I keep shifting the array elements to the right. So say for example 3 2 1, I'll take an unsorted array. 3 2 1, let me say I have 5 here and then 6. Now I want to insert 0 here. Let us assume now I want to insert 0 between, I want to insert a new value 0, this 0 between 2 and 1. Now what is that I have to do? Now I got to shift this towards the right, That is what I am doing here. So the last element, so the 6 which we are having, array 1 of I gives you the last element. So because I am initializing I to n minus 1. So what this gives in the first iteration is the last element, say 6. Now what we are doing, so this 6 we are copying it to array I plus 1. So from here, so we are copying it to the next position also. Hope you are following. So 6 gets copied here, and next in the next iteration what we do, we copy this 5 from here to this position. Getting? So because in the next iteration I will be decremented by 1, correct, no? So it will be 3. 3 plus 1 gives you the 4th position. Okay. So now it comes here, and then this 1 I got to shift here. Okay. 1 I got to shift here. Now what I'll do, this 1 will be replaced by 1, and this 0 should come to this position right now. So I'll delete this and I'll put 0. Same thing. So we are doing. Now after you find out the position, okay. So after you find out the position, you got to shift all your elements, towards the right. Shift all the elements towards the right and make space or room for this new element to sit there. Okay, that is what same principle what we are following. And finally, once it is done, all the elements are shifted. What I am doing, so the new element which I want to insert, so I am assigning it to array of position minus 1. Okay, array of position. Say if I want to insert here, now I would be reading the position as 1 2 3, but since the array index is starting from 0, I got to do it as 3 minus 1, that is 2. This is 0 1 and 2, because index it starts from 0 0 1 and 2. So now this is the proper position where you can go for inserting the new value. So array of position minus 1 is equal to element. I hope you understood why it is position minus 1. So strictly speaking, when you are reading the position, you won't be starting with the index 0. So say I want to insert a new element to the position 3. Now 1 2 3, I'll go with this convention. So in the program, since the array index is starting from 0, now I got to do position minus 1. Okay, so this 0 1 and 2. So 3 minus 1 will become 2, and you have the new value 0 get inserted here. Okay, now I'll, and then after inserting, you just go for displaying the array. Array after insertion is so and so. Okay, now I'll erase this. So if you want, you can add a watch window, and then you can go for observing all the values. I'll not do that now because I've shown a few examples by adding the watch window. Now you know, you learned how to do it. So I want you people to try that. Now I'll just run this program, compile and run. So yesterday when I ran this, there were no proper prompting messages, and it was confusing. So now the prompting messages are there. So one error it is showing. Let us check what it is. So printf undefined symbol, print it is saying. I think somewhere I have written print instead of printf. Let me check. Yeah, here. So instead of printf, I have written it as just print. Yeah, save the program. Now I'll compile it. Now I'll run it. Okay. Enter the number of array elements. So I'll take 5. Enter the array elements 2, 3, 4, 1, say 5. Now enter the position to insert the new value. So I want the new value to insert here. Okay. Between 4 and 1. Between 4 and 1, what is the position? So 2 is at position 1. I'll go with this convention. Right now 2 is placed at position 1, 3 is placed at position 2, 4 is placed at position 3. Now I want the new value to be inserted at position 4. I'll give 4. Now if I say 4, so the new value which I'll be inserting, it should come between 1 and 4 and 1. 4 and 1. So this is the position what I am reading. Now new element to insert, let me put it as 0. Okay. Now if I enter, so it is executed. Alt F5. So you can observe here. So 2, 3, after insertion 2, 3, 4 and 0. So 0 is placed at what? Between 1 and 4. You can observe the array before insertion, now array after insertion. Now the position what I have taken is 4. So now you have 0 inserted between 1 and 4. Okay. So position is 1, 2, 3, 4. It is at the 4th position. If you go with respect to the array indices, it is 0, 1, 2, 3, 3rd position. That is the reason we are doing it as position, array of position minus 1. So is it clear? Hello? Can I response please? Am I audible?
Yes, sir.
Yeah. So this is the last program which was there on the array. So now we'll go to the structures. Okay. I think, yeah, it's here. Yeah, all of you can see this structure.
Yes, sir.
Yeah. So we'll start with the introduction to structures. We understood introduction to arrays and many examples, around 16 to 17 examples on the arrays. So now similarly, now the structures. So array, you understood it was a collection of homogeneous data elements, but structure is basically used to build a collection of heterogeneous data elements. So in case I need to group the elements of different data types, so then I have to make use of the structure. Structure is basically called as the user defined data type, because you can go for making a collection of different types of data elements, or data elements of dissimilar types. Okay, so that is, so to group together a collection of data items of different types that are logically related to a particular entity. So that is what we call it as structure, and arrays will not help you in this manner. Okay, so what you can use is only the structures, because you got to group the elements of dissimilar data type. Say I need to specify the data related to a person, so obviously the person will be having some ID, so and the ID could be an integer value, and he'll be having a name, and name I cannot make it as an integer, I got to make it as a string. And similarly he may be having the age. The age, if I want, I can make it as an integer or a floating point. Say if I want to express 35 and a half year old, 35.5. So then that case I got to make it as a float. And similarly I can have gender also. Say whether the person is male or female. So gender I can have it defined as a character. So M for male and F for female, something like that. Now I need to group all these things, because these are all the logical data which are related to a person. Now I got to group them now, and that is possible through the structure. You can use structures in order to group the collection of dissimilar data types, and what dissimilar data types which are logically related. So we never go for grouping the data which are not logically related. Irrelevant data we never group using the structure, but structure we use for grouping only the related data. Okay, now so in other way, what you can say is a structure is a collection of variables of different data types under a single name. So you are grouping the data types of different data types under a single name. So that is what you are building your own data type. Okay. Now variables are called members here of the structure, and the structure is also called as user defined data type. That is what I was mentioning earlier. Okay. So the variables which you add or which you write inside the structure, they are called as the members of the structure, and in general the structure is also called as a user defined data type, because you are defining your own type by grouping the elements of dissimilar type. Now defining a structure, this is how the syntax goes. Okay. Now you got to use the keyword struct. So the keyword is struct for declaring a structure, and you have the name. So the keyword struct should be followed by the structure name, and again the structure name what we are writing is optional. Sometimes even if you don't write, structure name is also okay. Correct, no? That means if you want you can skip this. So this is basically an optional name. So that there is no mandatory rule that always a structure should be given a name. So but in general what we do, whenever we are creating a structure, we always try to prefer to give a name to the structure, and this structure name is an optional one. Okay. So in the next slide you'll understand how to write a structure without giving a name, since the structure name is optional. So and then inside the structure you can go for declaring the members. So first you got to define the data type of that particular member and member variable, name of the member variable, and similarly you can have any number of members inside the structure, and there is no limitation as such. So how many members can we have inside a structure? Is there a limitation to that? So no, there is no limitation as such. You can have any number of members declared inside the structure. And once the structure name is declared, once the structure is declared, a new data type, so then the variable of that data type can be declared as this. So now this I have given some name to this structure. Now how do I declare a variable of this particular type? Because I was mentioning the structure is also called as an user defined data type. So if it is a data type, it should be possible for me to declare the variables of that particular type. How do I do that? Something like this. So this is what the structure declaration part is, what you are seeing here. And similarly, now how do you declare a variable to your user defined data type? So this is, you got to make use of the keyword struct, and then name of the structure we are specifying here, and then the structure variable. Okay, this. Now this variable whatever you give here, it is of type this structure, or it is of type the user defined data type. Okay, and then members, there is an important note also. Members of a structure do not occupy memory until they are associated with a variable, with a structure variable. Say I have done this structure declaration, but I have not done any variable declaration to the structure. So none of these members which are there inside the structure, so they don't get the memory allocated. So they get the memory allocated, or they get the memory only when you declare a structure variable. Until you do the declaration of the structure variable, so none of the members inside the structure will get the memory allocated. So they get memory allocated the moment you're declaring a variable to the structure. So this is what is important, and you got to remember this. Next, so I have an example on it. So now what I have taken is, I want to define a new data type with the name student. Okay, so I am creating a structure with the name student now. Now use this is a structure name, and using this I can go for creating any number of variables of student data type. Okay, now this is a data type, new data type, user defined data type. And what this user defined data type comprises, it comprises of all these types. Now I can have a character array. So as one member I have declared it as name of 20 character array, and then integer roll number, and float marks, and character gender as I mentioned earlier, and long int phone number. So phone number also you can have. So for phone number I am giving the type as long integer because integer is not sufficient. So on a 16-bit machine, the size of the integer is 2 raised to 16 minus 1. So on a 32-bit machine, the size of the maximum size of the integer is 2 raised to 32 minus 1. So but the phone number usually comprises of 10 digits, so you got to make it as a long integer. Okay. Next, this is what the structure which I am creating for the student. Okay. Now how do I declare a variable of type struct student? Okay, this is all. So as I showed in the previous slide, so struct keyword and name of the structure, and then st. Now what is this st? St is a variable of type student. Okay, of type student, and using this variable you can go for storing the student name, student roll number, marks, gender, and phone number. All these things can be stored. Now this is one variable declaration what we have done here. Now what if I want to declare multiple such variables? So multiple student variables. So something like this: struct student st1, st2, st3. So now using this st1 I can go for storing information of one student, and I can use this st2 for storing the information of the second student, and using st3 I can go for storing the information of third student. So like this you can have any number of variables created for that purpose. So in case if there are a fewer number of students, say up to 10 or up to 5, so then this is okay. So you can declare the variables to the structure, something like this. If there are 100 students and it is not feasible for you to declare 100 variables, something like this. So do you think it is feasible for you to write the 100 variables like this? It is not at all feasible. Then you can go for having the array itself. You can make an array to this student. You can make an array of type student, and you can go for storing the information of each student. Say for example I have 100 students in my class, I'll make an array of size 100 of type student, and using the first index I can store the information of all this to one student. Using the second index of the array I can go for storing the information of all these things to the second student. So this is how it operates. I hope you people understood till here. So each variable of a structure has its own copy of the member variable. So now the member variables, how do you access them from the structure? So in the previous slide you understood you have the variables declared to the structure, and how do you access the members of the structure? That is by using the dot operator. Even in my first class I was mentioning about accessing the structure members using the structure variable. So this is the dot operator. Using the dot operator you can go for accessing each of the members which are there within the structure. So if it is a normal variable. Similarly, is it possible to have one second. Yeah. Is it possible to have the pointers declared to the structure? Yes, it is possible. If you have declared a pointer to the structure, instead of this dot operator, you will be using the arrow operator. Okay. So arrow operator, and in the first class when I was explaining, I have also mentioned and showed you how to write the arrow operator. You have to put an hyphen and then the greater than symbol. So that is the arrow operator. So if it is a pointer declared to the structure, then the members of the structures can be accessed by using the arrow operator. But in the previous example, it was a ordinary variable which was declared to the structure. Now you can access the members by using the dot operator. So if I want to access the name, so name of the first student, I can access it by using st1 dot name. So I want to access the roll number of the first student, st1 dot roll number. Now in case if I want to access the name of the second student, it is st2 dot name. Okay. So in case if I have made it as an array, then say I made it it as an array of st of size 100. So I can access the first student name by writing it as st of 0 dot name. And similarly, if I want to access the roll number of the first student, then I can access it by writing st of 0 dot roll number. So similarly, if I want to access the name of the second student, st of 1 dot name, it goes like this. Okay. So defining the structure, I have two ways here shown. This is what I have already shown you people. So I was mentioning that the structure name is optional. Okay. So this structure is defined by giving the structure name, and the same structure defined here without giving any name. Okay. There is no name given to this particular structure now. So when there is no name, but still you can access the structure members, but there are variables created to it. Okay. So the variables when you create, when there is no name given to the structure, and when you are creating the variables to the structure, you got to create it here only. So in the previous slide I showed you, you can create the variable like this, okay, like this to the structure. So this way it is not possible if you are not giving the name to the structure. In case if you are giving the name to the structure, you can go for creating the variables like this. If there is no name given to the structure, the variables can be declared to the structure like this. Along with the structure it should come. So just you end the curly braces, and after that immediately you specify all the variable names and you terminate it. And still, how do you access? So there is no name given to the structure, and still you can access all the structure members using the structure variables. How? st1 dot name, as we were doing here. See, when you were accessing the structure members, so you don't require the structure name. What you require is a structure variable. Okay. So st1 dot name, and how do you access here? Same, st1 dot name. So only thing is, so if you have the name given, an explicit name given to the structure, then it is easy for you to declare the variables even outside the structure. You need not do it inside the structure. Okay. I hope you are with me.
Yes, sir.
Okay. Yeah. Next, structure initialization. Now this is the syntax. Now I want to initialize, so I have just declared the structure, so and I want to initialize it. Now how do I do it? So struct, say I am giving this name of the structure, and this is structure variable is equal to, I can just give like this. Now in the previous earlier classes you understood how to initialize the array at the time of declaration. Correct? No? Same thing here also. Initializing a structure at the time of declaration. So this is what you are seeing is the syntax for initializing the structure at the time of declaration. So as you understood for initializing the arrays at the time of declaration, similarly here. Okay. So even arrays you understood how to initialize it at the time of execution, and similarly the structure can also be initialized at the time of execution or runtime. But what we are seeing now is how do we initialize it during the declaration time. So this is how you can do it. So the structure declaration is done, and you are creating the variable to the structure is equal to, open the curly braces, and you specify the values. Now how many values you got to specify here? The values whatever you specify here, it should be equal to the number of members which are available within the structure. And there is one-to-one correspondence. Now the value 1 which you specify here will be assigned as value to the first member. Value 2 which you specify here will be assigned as value to the second member of the structure, and similarly this will become the value to the last element. Okay. And yeah, and this is note what is written here is also very important. See, C does not allow the initialization of individual structure members within the structure definition template. So this is not possible. So what does it mean? Let me go back to the previous slide and show you. So is it possible for you to initialize here itself say character name of 20 is equal to some name? I want to write my name Harish Kumar BT. So can I do that here? No, not at all possible. Int roll number is equal to, say my roll number is 20. Int roll number is equal to 20. Can I do it here? Not possible. Okay. So that is what C does not allow the initialization of individual structure members within the structure definition template. You got to do it outside. How to do it? Like this. Okay, you got to use the keyword struct and specify the name of the structure, specify the variable name is equal to, and specify the values in the order in which the members are declared inside the structure definition template. Okay, and you cannot interchange this. Okay, so because there is one-to-one correspondence. Now here we have an example. So I said initializing the structure. See, the structure is defined here. This is the same structure which I showed you in the previous slide. Okay, main. I am initializing it at the time of this initialization is not during the runtime. It is during the declaration time. Struct student. I am declaring a variable of type st1. So st1 as what? Student, and I am initializing name of the student, roll number of the student, and then marks of the student, gender male or female, and then the phone number. Okay, we are initializing. This first value is taken and assigned as value to name, and the next one is taken and assigned as value to the roll number, and this is assigned to the marks member, and this is the value which will be assigned to the gender, and this is the one which will be assigned to the phone number. It is in this order. Okay, and finally we are printing the same. Now how do we access? Same. Now I want to print the name of the first student, st1.name. Okay, so I'm using the variable name, and to access its value, name st1.roll number, st1.marks, st1.gender, st1.phone number. Okay, this is just an example to show how the structure is initialized at the time of declaration. Next. Okay, now what we did here in this example, so how many members were there in the structure? 1, 2, 3, 4, 5 members. And have we initialized all the 5 members here? Yes, we have initialized all the 5 members, because you can see inside the initialization there are 5 values. 1, 2, 3, 4. 5 members and 5 values. So this is what is full initialization. So complete initialization of the structure. Is there a possibility of doing partial initialization also? Yes, you can do partial initialization as well. How to do it? Okay, so we can initialize the first few members and leave the remaining blank. So this is what is partial initialization. So there is no mandatory rule saying that when you are initializing the structure at the time of declaration, you have to initialize all the members. Even you can go for partially initializing your structure. However, there is one thing which you got to remember: the uninitialized member should be only at the end of the list. So they should be only at the end of the list. The uninitialized members are assigned the default values, something like this. So if you have some member of type integer or floating point numbers, so by default they get the value as 0, and if the member is of type character or string, then it gets a null character. So I hope all of you know this slash followed by 0. So this is not slash O, it's a slash followed by 0. Okay, slash followed by 0, and what is this called as? A null character. Okay, so if the member is of type integer or float, it gets a default value 0. If the member is of type string or character, it gets the default value as null character slash 0. So partial initializations are also possible, and with one constraints or condition. What is it? The uninitialized members should be only at the end of the list. You cannot have the uninitialized member of the structure present at the beginning of the list. Okay, I have the example, I'll show you. So just look into this example. So struct student. So I have not taken all the members which were there in the previous example. Now we have only the name, roll number, remarks and marks. Okay. Now just look into this. Observe initialization. Struct student S1 is equal to name and 4. So the first member is getting initialized with name. Okay. And then second member is getting initialized with 4. And what goes to this remarks? Can you tell? You can have uninitialized members of the what? Structure present at the end of the list. Correct, right? See that, so this name goes to this, and this 4 gets assigned to roll number, and any idea what gets assigned to remarks?
0.
This no, it is not 0, because I showed null character, and for marks it is 0.0. 0.0. So if I say this is int marks, so what gets initialized to marks is 0, and so since I've told it as float marks, so the marks gets initialized with 0.0. So this is it. Okay. So only thing is the uninitialized members, the members which you don't want to initialize, so they got to be at the end of your member list. So I cannot write them. Say I want to do partial initialization. Can I write these two before and these two later? Here, not possible. Can I exchange the position of these two? Say I am writing these two here and these two next, and I am writing struct student S1 is equal to name comma 4. Will it work? No, it will not work. So that is what the constraint is. So if you are interested in doing the partial initialization, the members, so whose initialization you are not doing should be there at the end of the member list. So now we have character, remarks and float marks present at the end of the member list. Okay. And next goes. So and we are printing also. So if you take this program and if you try to execute it, so name, it says name, and roll number will be printed as 4, and for what is the value that gets printed for the remarks is null character. Okay, and for marks it will print 0.0. So like this. So either you can go with the full initialization, or else you can also do the partial initialization, but you should know what are the values that get assigned to the members that are not initialized. What are the default values that gets assigned? It's easy. For float, if the type of the member is integer or float, it gets the default value as 0, and if the type of the member which is not being initialized is string or character, it gets the default value as null character. And one more important thing that you should remember is the members that are not initialized should be always at the end of the member list. Okay. Now accessing the member of the structure or processing a structure. So if you want to do some kind of processing or some kind of computation by accessing the members of the structure, so this dot operator plays an important role, because without using the dot operator it is not at all possible for you to access any of the structure members. Okay, so this you already know. And the other operator which can be used to access the structure members with the pointers is arrow operator. Now question here. Now I want you to do this quickly. Create a structure named student that has name, role and marks as member. Assume the appropriate types and size of members. Write a program using structure to read and display the data entered by the user. Okay, simple. Now you got to create a structure with the name student, and the student structure should have the member name, role and marks as members. Assume the appropriate data types. Now what data type you will assume for the name? So it is a character array. Okay, and then what data type you will assume for roll number? Integer, obviously. And then or otherwise, say I don't want to make it an integer, I want roll number also to be made it as, say for example your USN is a combination of digits as well as characters, 10. So I want to make it as an array of 10, array of size 10. Okay, no problem, you can do it. And marks, so left to your a view. Say I don't want the marks to be a floating point value. I want the marks to be only integer. Make it integer or floating point also, and then write a program to read the values for all the structure members and print the same. So do it and put it in the chat box.
So do we write in one notebook or just type it over there?
Yeah, if you write it in the notebook, how can I see? Just put it in the chat box.
Okay.
Yeah. Uh, 48, 50, 51 ಇದ್ದಾರೆ ಸರ್.
ಒಂದೇ ಸೆಕ್ಷನ್ ಸರ್?
ಹಾಂ, ಒಂದೇ ಸೆಕ್ಷನ್.
21ನೇ ತಾರೀಕಿಂದ ಬರ್ಬೋದು ಅಂತ ಅವರಲ್ಲ, 9ನೇ ಕ್ಲಾಸಿಂದ ಡಿಗ್ರಿವರೆಗೂ.
ಹಾಂ,
ಈಗ ಅವ್ರು ಬಂದರೆ ಮತ್ತೆ ಸ್ಟಾರ್ಟಿಂಗ್ ಇಂದ ಮಾಡ್ಬೇಕಾ, ಇಲ್ಲ ಈಗ ಮಾಡಿರೋದು ಬಿಟ್ಬಿಟ್ಟು ನೆಕ್ಸ್ಟ್ ಮಾಡ್ಕೊಂಡು ಹೋಗ್ಬೇಕಾ?
ಇಲ್ಲ, ಈಗ ಮಾಡಿರೋದು ಬಿಟ್ಟು ಮಾಡ್ಬೋದು.
ಈಗ ಮೆಸೇಜ್ ಹಾಕಿದ್ರು ನಮ್ಮ ತಮ್ಮನ ಮಗನಿಗೆ 21ನೇ ತಾರೀಕಿಂದ ಪೇರೆಂಟ್ಸ್ ಕರ್ಕೊಂಡು ಬಂದು ಅದೊಂದು ಲೆಟರ್ ಏನೋ ರೆಡಿ ಮಾಡೋರಂತೆ, ಅದಕ್ಕೆ ಸೈನ್ ಹಾಕೊಟ್ರೆ ನೀವು ಬರ್ಬೋದು. ಬೆಳಿಗ್ಗೆ 8 ಗಂಟೆಯಿಂದ 12 ಗಂಟೆ, 1 ಗಂಟೆಯಿಂದ 5 ಗಂಟೆ, 4 hours ಶಿಫ್ಟ್ ಮಾಡಿದ್ದಾರೆ ಸರ್, ಭಾಗ ಮಾಡಿದ್ದಾರೆ. ಒಂದು ಸೆಕ್ಷನ್ಗೆ 30 ಜನ 40 ಜನ ಇರ್ತಾರೆ ಸರ್, 20-20 ಜನ. ಬೆಳಿಗ್ಗೆ ಬೇಕಾ ಸಾಯಂಕಾಲ ಬೇಕಾ ಬರ್ಕೊಟ್ರೆ ವ್ಯವಸ್ಥೆ ಮಾಡ್ತೀವಿ ಅಂತ ಮೆಸೇಜ್ ಹಾಕಿದ್ರು.
ನಮ್ದು ಇನ್ನೇನು ಮೋಸ್ಟ್ಲಿ ಅಕ್ಟೋಬರಿಂದ ಅದೆಲ್ಲ ಸ್ಟಾರ್ಟ್.
21ನೇ ತಾರೀಕಿಂದ.
ಬಟ್
ಸೊ ನೆಕ್ಸ್ಟ್ ವಾರ ಅಲ್ಲ, ನೆಕ್ಸ್ಟ್ ವಾರದಿಂದ.
ಸೊ
ನೀವು ಈ ಮುಂದಿನ 14ರಿಂದ 19ವರೆಗೂ ಬಂದು ಬರ್ಕೊಟ್ಟು ಇದು ಮಾಡಿ, ಯಾವ ಟೈಮಿಂಗ್ ಬೇಕು ನಿಮಗೆ, ಬೆಳಿಗ್ಗೆ ಬೇಕಾ ಸಾಯಂಕಾಲ ಬೇಕಾ ಏನು.
ಸೊ ನ್ಯೂ ಗೈಡ್ಲೈನ್ಸ್ ಕೊಟ್ಬಿಟ್ಟು ಸೊ ದೆಲ್ ಸ್ಟಾರ್ಟ್ ಆಫ್ಲೈನ್ ಕ್ಲಾಸಸ್.
ಒಂದು ಡೆಸ್ಕ್ಗೆ 2 ಗ್ರೂಪ್ಸ್ ಆಗುತ್ತೆ. 40 ಜನ ಇದ್ರೆ ಭಾಗ ಮಾಡಿದ್ರೆ ಆಗುತ್ತಾ ಸರ್?
ಮಾಡ್ಬೋದು. ಸೊ ಕ್ಲಾಸ್ ಸ್ಟ್ರೆಂತ್ 60 ಇದ್ದರೆ 2 ಬ್ಯಾಚಸ್, 30-32 ಬ್ಯಾಚಸ್.
ಇವರು ಅದಕ್ಕಿಂತ ಫಸ್ಟು ಮೆಡಿಕಲ್ ಇಂಜಿನಿಯರಿಂಗ್ ಸ್ಟಾರ್ಟ್ ಮಾಡಿ, ಆಮೇಲೆ ಡಿಗ್ರಿಗಳೆಲ್ಲ ಸ್ಟಾರ್ಟ್ ಮಾಡಿ, ಆಮೇಲೆ PUC ಸ್ಟಾರ್ಟ್ ಮಾಡಿ, ಆಮೇಲೆ 9-10 ಸ್ಟಾರ್ಟ್ ಮಾಡ್ಕೊಂಡು ಬರ್ಬೋದಾಯ್ತು. ಚಿಕ್ಕ ಹುಡುಗರು ಏನಲ್ಲ, ಇವಾಗೆಲ್ಲ ಈಚೆ ಕಡೆ ಇರ್ತಾರ ಸರ್, ಯಾರಾದ್ರೂ ಅಲ್ಲ ಮನೆ ಒಳಗಡೆ ಇರ್ತಾರ ಸರ್, ಯಾರಾದ್ರೂ PUC ಹುಡುಗರು ಮನೇಲಿ ಇರ್ತಾರ, ಇರಿಸ್ಕೊಳಕ್ ಆಗುತ್ತಾ ಅವ್ರನ್ನ ಓದಿ?
Just write the structure declaration part, and if you want, you can go for initializing the structure there itself, declaration point initialization, and print the same. So no, we want to initialize the structure at runtime, then microphone is muted. If you want to initialize the structure at the runtime, so then use the scanf statement and read the values for all the members, and then go for displaying them. So put your answers here in the chat box. Yeah, keep writing. I'll just go with the next slide. Okay, this is the answer. I'm just showing you the answer now. Answer for the previous question. So the structure, a character, name of 20, int roll number, float mark, and then so we are reading it here using getS. Yeah. So we are using to read the name. We are using getAs. I hope all of you know getAs, get string. Okay, getAs. So which is an unformatted input output statement. So get C, get a character to read a single character, which is an unformatted statement. And then
So we cannot see your screen.
Oh, sorry. Oh, one second.
ಸರ್ ರೂಮ್ ಕೀ ಅದು ಸ್ಯಾನಿಟೈಸ್ ಮಾಡಿಸ್ಬೇಕಾಗಿತ್ತು ಅವರು ಇಬ್ರು ಬಂದಿಲ್ಲ.
One second. Sharing is stopped. I'll do it. Yeah, you can see now.
Yes, sir.
Yeah. See, printf. This is the structure declaration, and then the variable declared to that is yes, because I want to read only one student data. So struct student yes. So clear screen, and then enter the name. Now what I'm using to read the name is getAs, get string. Okay. So this is an unformatted IO statement. So getAs, get C, put C, put S. Okay, all these are all unformatted IO statements. And if you don't want to use getAs, which is an unformatted one, say I want to use the formatted IO statement, then you can also do it by using scanf and printf are the formatted IO statements. You know that. And then reading the roll number here, and then enter the marks. I'm reading the marks here, and then finally printing them. Okay, so this is the solution to the previous question. Okay, now copying and comparing the structure variables. Even when we were discussing arrays, I showed you one example program for copying the elements of the array, from one array to the another array. Okay, so that was possible. It was possible for you to copy the elements of one array to the another array. Now, is it possible to copy the one structure to another structure? Okay. Say I have two variables of the same structure type. Okay, two variables of the same structure type can be copied in the same way as ordinary variables. If student 1 and 2 belongs to the same structure, then the following statements are valid. I can say student 1 is equal to student 2 and student 2 is equal to student 1. Okay. However, the statement such as this cannot be applied. Okay, that means if both belong to the same structure, then you can do this. Okay, student 1 is equal to, say I'm assigning student 2 to student 1 or student 1 to student 2, but this is not permitted. So you cannot say whether student 1 is equal to student 2 or student 1 not equal to student 2. So this type of comparisons you cannot do. But so if two or more variables they belong to the same structure, so then you can assign them like this, but this is not permitted. And if we need to compare like this, I want to check whether student 1 is same as student 2. So then we need to compare the structure variables. So we may do this by comparing the members individually. Okay, so one by one you got to compare it. How? Here in this example I have. Okay, see, I have the student structure declared here, name and roll number, and I'm initializing here. So this initialization and I'm declaring, see, another variable student 2 for the same structure. Okay, so this student is also for this structure, and student 2 also is of type this student. Now I can say this student 2 is equal to student 1. Now what will happen? So the same values what you'll find, what you're finding for student 1, A, B, C and 4 gets assigned to student 2 also. Now if I say student 2 dot name, what it gets printed? What it prints? A, B, C. If I say student 2 dot roll number, what it says? 4. And student 1 dot name, again A, B, C. Student 1 dot roll number, again 4. I get the same thing. So I'm printing it here. Now this should print me out the same thing. Okay, it should print me out the same thing. And next, if string compare, I hope you know there's a built-in function to compare two strings. So string student name, student1 dot name, comma student2 dot name equal to 0. If both are same, okay, what strcmp returns is 0. So 0 equal to 0 and roll number is equal to roll number, okay. So then you say students are same, okay. Now what I'm doing here, I'm comparing, I'm not just writing them as student1 is equal to student2. So OP people understood what I mean to say. Student1 double equal to student2. I cannot do like that, okay. Now in case if I want to compare and say these two students are same, so I got to do it individually, member wise, okay. So I'm just here comparing the name of the first student with the name of the second student. If both are same, what strcmp returns is 0, equal to 0, and another condition. Now student1 roll number is equal to student2 roll number. So since this is an integer, you can use double equal to operator and you can compare. But names are strings, you cannot use double equal to operator. So you can always use the built-in function strcmp to compare and say whether two strings are same or not. And this is also true, this is also true, because and is the operator which you are using. So both are true. You just say students 1 and 2 are same. I hope you people understood till here. So is it clear?
Yes, sir.
Yeah. You can assign one variable to another variable provided the variables are to the same structure. If the variables are to the same structure, if variable, so student 1 and 2, they are the variable to the same structure here, assignment can be done, but when you are comparing, it cannot be done by using the variable names of the structure. Even though they are the variables to the same structure, so the comparison cannot be done by either using the double equal to or not equal to, all these things. So it has to be done on individual member wise. Okay, now how structure elements are stored. Now in this, how structure elements are stored, let me take this example and come back, go there. I have structure student declared. So what is the memory allocated to this structure right now? Okay, and how it is stored in the memory? It is stored contiguously, one after the other. Say first the memory will be, what is the memory allocated to this? 20 bytes, because character takes 1 byte, but this is name of 20. How many such bytes are allocated? 20 bytes are allocated. So for this member, 20 bytes of memory is allocated. And if you just look into the second member, it is integer. So assuming it's a 16-bit machine, now what is the size of the integer? 2 bytes. Okay. So here 20 bytes and here 2 bytes. 20 plus 2, how many bytes of memory is allocated? 22 bytes of memory is allocated. And how are they allocated? Are they allocated in pieces or they continuous? They are allocated continuously. Okay. So from say the starting address of this name is say 2000, from 2000 till 2020, and this gets 2 more bytes of memory allocated, 2021 and 2022. So it is continuously allocated from 2000 to 2022. This is how the memory gets allocated for the structure. And the sum of the memory allocated to the structure is the sum of the memory required for each of the individual members of the structure. Okay. Allocated is, and there is one more thing, there is something called as slack bytes also. Okay. The computer, while storing the structures, okay, or storing the members of the structure, it uses the concept called as word boundary concept. Now why it uses word boundary concept? Just to make sure that the structure members are accessed much faster, or accessed in an efficient way. Okay. So if this concept word boundary concept is followed, so it's possible for the CPU to access the members of the structure in a much faster rate. Now, and this preserving this concept, word boundary concept, creates something called as slack bytes. Okay, and this you'll understand in the next slide very clearly. So I have the example I made with an example. I hope all of you can see this. Let me zoom it a little bit. Can you see this now?
Yes, sir.
Yeah. See here, I have the struct employee created, character array I have, int id I have, double salary I have. Okay. So 3 members are there. Now, and I already told the memory to the structure members will be allocated continuously. Now we have the memory allocated for character now. Name of 8. So 8 characters. You can see here. Memory. So the address is starting from 2000 and it is going till 2007. And next you have int id. Okay, 4 bytes of memory is allocated here. 4 bytes of memory, because I'm assuming it's a 32-bit machine. On a 32-bit machine, the size of the integer is how many bytes? 4 bytes. So 4 bytes of memory is allocated. And then double salary, you can see here some slack bytes are there. Slack bytes. So unfilled bytes. And next the memory is allocated from where? 2016. And size of double is how many bytes? 8 bytes. Okay, 1, 2, 3, 4, 5, 6, 7, 8. Till here 8 bytes of memory is allocated. Now why this bytes are left out? Okay, nothing is filled here. So but what is the actual memory allocated? What is the actual memory required for this? 8 bytes plus 4 bytes, 12 bytes plus 8 bytes. Total 20 bytes of memory is required for this particular structure. Okay, so here 8 bytes is allocated, here 4 bytes is allocated, and here the remaining 8 bytes. Total 20 bytes of memory is allocated. But so even though I tell the memories are allocated contiguously, if you want to preserve the concept of word boundary, so this is a slack created. Now what is that word boundary concept is? When you are allocating the memory should be allocated, the memory address which you allocate, it should be the multiple of the size of the data type. See, what is the size here? Character array it is. What is the size of one character? 1 byte. So it can be allocated anywhere. Okay, because 1 is multiple of 1. So you can allocate here 2000, or you can go to 2001 or 2002. Next, if I just look into this, okay, id integer type it is. How many bytes it takes? 4 bytes. It takes 4 bytes, and where this can be allocated, so at an address which is multiple of 4. Okay, multiple of 4. Now but see, 2007 my character array is ending, and 2008 I'll check 2008. So you got to check whether 2008 is multiple of 4. Yes, 2008 is a multiple of 4. So and you can use this. Okay, and next I come here double. So and we have the integer occupying from 2008 to 2011. So the next byte available is at address 2012. And what is my double? The next member type is double, and it is of how many bytes? 8 bytes. Now I got to check whether this is 2012 is a multiple of 8. So 2012 is not a multiple of 8. Okay. Now I cannot, and I'll check with 2013. Your 2013 is also not a multiple of 8. 2014 I'll check. It is also not a multiple of 8. 2015 I check. It is also not a multiple of 8. Now 2016 I check. Yes, 2016 is a multiple of 8, and this is the memory. From here it starts. So these are called as slack bytes. And why we are using the concept of word boundary? Just to make sure that the members are accessed at much faster rate. So if this concept is followed, so it is easy for the CPU to access the member from these memory locations easily. Okay, so this is what these slack bytes. So we'll stop here, and we'll continue in the next session. If you have any doubts or queries, you can ask me now. Is the concept of slack bytes clear?
Yes, sir.
The word boundary concept is clear?
Yes, sir, got it.
Yeah. So we don't count them. So when if I ask you a question, what is the memory allocated to this structure right now, your answer should be how much? 20 bytes. So we don't count them. They're left out bytes. So we have not assigned anything to them. The total memory allocated to this structure is 20 bytes. Okay. Yeah.
So what is the use of slack bytes?
No, the only thing is we have not assigned anything to this. Okay, we have not assigned any data to this. Why we are doing it? Just to make the CPU easily access the data, because if the data is stored at the addresses which are multiple of the size of the data types, the CPU can access it much faster. That's all. So there is no use as such. Just to make the efficient and easy access of the structure members by the CPU, so we are using the concept of what? Word boundary.
Oh, okay,
Yeah.
sir.
Yeah. Is that clear?
Yes, sir.
Yeah. So I'll download the attendance list, and after that you can leave. And yeah, it got downloaded.